So welcome to the sixth lecture of probability and statistics. पिछले लेक्चर में क्या किया हमने? आप लोग ग्रुप्स में आ रहे हैं, ग्रुप एक लेक्चर में आता है, दूसरा लेक्चर बेचारे नहीं जाते. कोई था पिछले में? क्या किया हमने? Right. So we discussed mean, variance, and we wanted to start covariance. Yes. तो क्या है इनमें common theme क्या है? What are they? ये सब क्या है? Moments कहलाते हैं. They are called moments. But why do we work with them? क्या थी motivation? To have some representative parameters from the distribution. Right? So we like your GPA, you have every semester's GPA, but then you represent the whole performance usually by CGPA, right? Take a representative value. So for the statistics of a random variable, the probability density or the distribution function PDF covers everything, but often we don't need that much information. What we want to work with is the representative values. उसमें मैंने आप बताया the three key ones that we like to use. इस पे copy करते हैं desktop. Right. So the ones we like to use are the moments, the mean, variance, and covariance. Right. So क्या था mean क्या था? याद है किसी? What was the mean of a random variable? Right. थोड़ा सा उस पे साथ साथ करें रिवाइज वगैरह, लेक्चर भी अपलोड हो चुका है. So mean is the center of mass of the distribution, or it's the expected worth of the random variable. Right. We also call it the location parameter, which tells us okay where the distribution is mostly located. Now we discussed that in detail last time. So for a random variable, that is mean, we had mean, variance, and covariance, and then I mentioned cousins of these, mode, etc., that you can see on your own. These are the key information about the statistics of a random variable. Now for the mean, we developed it in great detail last time. I won't repeat the whole thing, just read or view the lectures. So mean represents, okay, what is the expected worth of a random variable. Let's say a random variable can take two values. Yeah, it can take a value 10 and it can take a value minus 10. Okay. So if it takes the value 10 and minus 10 with equal probabilities, let's say the chances of this happening are 1 by 2 and the chances of this happening are also 1 by 2, then what is the expected worth of this random variable? Well, basically, if you sum this, what you get? 0. Yeah? Now, what does that represent? It says, if this random variable, for example, takes values 10 times, yeah? That's the आप इसको observe करते हैं. Yeah? 50% of the times it will take a value 10. Other 50% of the time it will take a value minus 10, right? So if you sum them up, इसकी total value तो overall average value इसकी क्या बनती है overall 0 बनती है. Yeah. Now, if there is another random variable, let's say y or something else, that takes value 1000 or a value 10, yeah, it takes two values. Okay. Now, what's the expected value of this random variable? From here you cannot tell. हो सकता है आपने इसका average निकालें. Yeah, that you do when you have no information, other information about the random variable. Now, if I tell you, it looks like that its average value can be rather high, but what if I tell you that it takes this value, the 1000 value, yeah, with just a probability of 10 to power minus 9. The probability of this variable taking this value is very low. Now, even though the value itself is high, it doesn't show up very often. Yes? So the expected worth of the variable is not the value it can take alone. It's also multiplied by the chances of those values showing up. Yeah, and we did that in great detail. So this will be then, if it can only take two values, then the probability of 10 happening will be 1 minus 10 power minus 9, because the two should sum to 1. There's only two possibilities, so the total probability should be 1. So like that, and we summarize that. Yeah, how did we summarize that? As the expectation operator, and we also saw the moments, center of mass interpretation. Yeah, so very quick revision. What did we say? The expected value of a discrete random variable was summation whatever values it can take. Yes, x1 2 3 4 ढाई से कितनी values लेता है 6. Yeah, similarly whatever discrete set of values it can take, multiplied by the probability of that each of those values showing up, like here. Yeah, actual value it can take times what are the chances that that value will show up. You multiply those out, sum them, and you get the expected value. ये होती है expected value, the mean value जिसको आप कहते हैं. Right? And we saw last time also that this also reflects the center of mass. So for the first case, the variable can take a value of minus 10 or 10. Yes? And this has a weight or probability of half, and this has a weight probability of half. Then the other interpretation of the mean as the center of mass is what? You have to put a wedge here such that the force applied multiplied by the moment arm balances out. Yeah, अगर आप wedge इधर रखेंगे तो ये beam will fall to the right. Yes, if you put the wedge here, it will fall to the left. थोड़ा सा इधर रखेंगे, again imbalance होगा. It's easy to judge in this case that कहाँ आएगा balance point? 0 पे. Why? Because the moment arms are equal. The forces they are applying, the weights they hold, the likelihood, the probability they have are also equal. So it's 0, it's at 0. What about the second case? Now in the second case, one possible value is a 10. Then let's say 10 is here. And the other possible value is far away, it's a 1000. Yes? Now you may think, okay, I'll put the wedge smack in the middle. Yeah? That would be fine when the two have equal probabilities. Then if you put that in the middle, the balance will be fine. Yeah? But look what I gave you. This guy had an extremely low probability, and compared to this one which had a very high probability. Yeah? So then you have to find where to put the wedge. And that place where you have to put the wedge, mu x, let's call it, will have to do what? Whatever this moment arm, right, and this moment arm multiplied by probability of this value, probability of this value. If you sum them, in the last lecture we started from here also and got back to this formula again. So this formula shows up both ways, and that is why both interpretations of the mean values are fine, and we did that with several examples. This was a very quick revision. So when we draw probabilities or distributions, we also say that the mean shows you, okay, where is the probability located. For example, heights of people often, so they cannot be negative, the heights of people, the mean may be somewhere here at 170, say 5 centimeter. Yes, it shows you, okay, where the probability located. Lengths of whales. Yeah. Now, even though they may have a similar shape, medium, very few, very short, very few, very long, but overall maybe a similar shape. But you expect their mean to be here or to the left. Lengths of whales to the right. Yes. So whatever the shape, most likely it is going to be the well shape. But we expect the whole distribution to be a bit to the, actually quite a bit to the right. Whales काफी बड़ी होती है, yeah. So that's why we often call the mean also the location parameter. It gives you a feel of where my distribution is. Yeah. Okay. For symmetric cases, the mean is always in the middle. Now you can see if you put the wedge here, yeah, the total weight applied by each infinitesimal multiplied by that distance would be same. And this is a continuous case, and I've mentioned in continuous cases, what will the only thing that will change is integral will replace summation. Yes. So what about variance? याद है किसी को variance क्या था? So let's say this is one random variable that has mean here. Let's talk about another random variable like this. Also same mean. Yeah. The degree of variation in the data. Yes. And for that we said, okay, how did we define it? This was our definition of the variance. Notice that the variance is using the mean here. So what is it saying? How much the random variable deviates from its mean in the square sense. And I told you why square, we discussed that last time. On average. Okay, so that is all. How much deviations are there and what is the likelihood of those deviations? If you write it out in terms of a discrete variable, it will come out to be something like xi minus mu x square times the probability of fxi showing up overall xi. So how much deviation from the mean multiplied by probability of that deviation showing up. Yeah, that is the variability. कितना उसके अंदर variance है. So it's usually a good parameter to show how much your data is spread out. Okay. Now, the third thing we were looking at when we stopped last time, the third moment was covariance. Yeah, and we started developing that by talking about a particular case where we said, and that is where we start today's topic, the covariance. We said, okay, let there be a random variable z, which is actually a sum of two other random variables. Now, if you remember, when we started with probability, we did probability of event A, single event. Yes? Then what did we do? We went to two events. Probability of A and B. A or B. A given B. Yes? Similarly, we started the PDF, the probability distributions and density functions. We said f of x. Yes? But then where did we go? Two random variables. Fx, y. Fx given y. Same here. Mean and variance apply to a single random variable. उसकी अपनी होती है, single की होती है. A random variable x has a mean value. A random variable x has a variance. Okay? But what about statistical relation between two random variables? उसके बारे में हम क्या measure use करते हैं, right? The full distribution we use are fxy, the joint, for fx given by the conditional, that's fine. But again, just like fx and fy, this is too much information. We are often only interested in, okay, do they vary together? So today we will see that in some detail. Now let us assume that I know the mean and variance of this. First random variable are mu x and sigma x squared. The mean and variance of the second random variable are mu y and sigma y squared. These are constants. Yeah. So we saw last time then what is the mean of z. We saw that expectation operator is linear. So it's simply a mu x plus b mu y. Simple. Yeah. But the tricky part is what's the variance of z? Sigma z squared. Yes. So we go back to the definition. What was the definition of variance of any random variable? We did that last time. It was you see how much the random variable deviates from its mean in the square average sense. Yes? And if you apply this, now how will you apply this? Z, you have a function for z. Put that here. Yes? Mu z, you have a function for mu z in terms of two other random variables, x and y. And when we solve this, it leads to this interesting thing which we actually want to come to. I won't do the steps, it's very simple, but you can try. It will be a square sigma x square plus b square sigma y square plus 2ab expected value of x minus mu x times y minus mu y. This is interesting. Yeah. The first term is just one variable. Yeah, the variable x, variance of that. The second relates to the second variable. But this term is quite interesting as it is talking about इसके कोई interpretation कर सकता है? क्या कह रहे हैं? Can you read it? Read, interpret it. Yeah, doesn't talk about that. So what is it saying?
Joint variance.
Yeah, the covariance. We have a name for that. But if you want to interpret it, like here we are saying, what is it this saying? How much does z vary from its or deviate from its? This is a deviation, and standard deviation is the word for square root of variance. How much does z deviate from its mean in square average sense? Yes? Overall. तो यहाँ भी ये क्या है? अब तो दो हो गए. Yes? It's not just talking about single x, but not just talking about
Multiple of x and y, the variance.
yeah.
Variance.
So we have a name for it. We call it the covariance of x, y. Just like we probability PDF, we went from single variable to double. Here we are now going to look at two of this. What it's really saying is this. Okay, I will discuss that in more detail, but just first trailer here. If x goes above its mean or deviates from its mean, does y also deviate from its mean in the average sense or not? Okay, अगर दोनों की वैल्यू हाई होगी deviations की इकट्ठे, together they deviate, you expect this product to be larger. Yeah. So I will discuss this in some detail now, but first let me give you the statement. Mean is what? The center of mass or expected value, expected worth of a random variable. Variance is what? The degree of variance or degree of spread in the data. Yeah. This guy tells us how much linear statistical relation there is between two random variables. Linear statistical relation. आपको linear deterministic relation का पता है between two variables. क्या होता है उसका formula? If y and x are two coordinates, वेरिएबल हो गए, क्या होती है उनकी डिटर्मिनिस्टिक लीनियर रिलेशन? इक्वेशन ऑफ अ लाइन y इक्वल्स mx प्लस c, राइट? उसमें कुछ रैंडम नहीं होता, राइट? एक स्लोप होती है, एक इंटरसेप्ट होता है. Put the value of m, get the value of put the value of x, get the value of y. You know linear relationship in the deterministic world. Yes, as I said in the first lecture, this course is about taking the math you know for the deterministic world and now tailoring it for the uncertain world. Yes, now in the uncertain world, a simple line won't work. Okay, so in that case, like in a deterministic world, if two things are linearly related, they will just go like this, no issue. Okay? In the probabilistic world, even if they are linearly related, there will be some errors, some variations. पता है किसकी जगह लगाएगा आपको? आप कौन सी लाइन लगाएंगे इसमें? एक तो नहीं लग सकता. Yeah, but still you want to see, okay, is there some linear statistical relation? If one goes up, does the other go up on average or not? Yeah. So first, keep this in mind. Covariance is what? It's the degree of linear statistical relation. And now I'll try to clarify it with some examples. Let's look at the homework marks of two students. Yeah. Let's erase this. So, student A and student B. There are several homeworks and these are their marks: 8, 7, 10, 10, 3, 4, 0, 1, 6, 7, 2, 1, 5, 6. One, two, three, four, five, six, seven, eight. Okay, eight homeworks we gave in some course, and student A got these marks, and student B got these marks. कुछ इसमें कुछ नजर आ रहा? क्या नजर? पैटर्न नजर आ रहा? क्या है?
वो स्टूडेंट बी जो है वो एक नंबर ज़्यादा ले
एक नंबर ज़्यादा ले रहा है.
सर कहीं कम भी ले रहा है, ज़्यादा ले रहा है, लेकिन only 1 mark difference in most cases.
Okay.
Except second case के अंदर जिसमें दोनों को रहा.
हाँ, यही होता है प्रोबेबिलिटी में. अगर तो सब कुछ सही खिंचा रहा हो, then you go deterministic, draw a line and everything is fine. तो थोड़ा बहुत वेरिएशन आ जाती है. So but उसके अलावा क्या पैटर्न? Do you see any other pattern? You are looking for deterministic patterns now, right? कि एक का डिफरेंस है या नहीं है. आप थोड़े से और सोचे. Homework. Let me ask, what happened in homework 4? Or even let's say homework 6. क्या हुआ? दोनों के लो है, राइट? मफिया में क्या कर रहा है? एवरेज है तो एवरेज है. सो क्या नजर आ रहा है?
तो शुरू और आखिरी के होमवर्क्स के अंदर ज़्यादा मार्क्स हैं जो सेंटर में अगेन
वो तो हो गया ना. इंडिविजुअल भी आप देख के कह सकते हैं, है ना? अब दोनों को देख के बताएं कि दोनों का आपस में क्या रिलेशन बन रहा. जी काफी कॉमन आप लोग माशाल्लाह करते हैं ना. If one of them gets high marks, the other is also getting high marks. If one gets low marks, फिर तो कॉपिंग चल रही है most likely, right? एक के मार्क्स हाई आते हैं तो दूसरे के भी हाई आ रहे हैं. एक के एवरेज हैं तो दूसरे के भी एवरेज आ रहे हैं. If one of them gets low marks, the other also gets low marks. What's happening? It seems there is some sort of relationship between their marks. क्यों हो रहा है? क्या वजह हो सकती है? एक तो आप समझ आ रही है इसलिए आप हंस रहे हैं, राइट? कॉपी लेकिन कोई वजह नहीं. आई टेल यू दैट
एक उस पेपर एक मुश्किल है.
Yes. So वो हम we will discuss that. It doesn't mean if they have covariance, high covariance, that doesn't mean one is causing the other. Something else might be causing both of them. Yeah. but at least you can establish कि okay कुछ तो हो रहा है. Either one is causing the other, meaning either A is copying from B or B is copying from A, or there are some other circumstances that are causing them to co-vary, right? Both go up. आसान assignment आती है या टाइम ज़्यादा मिलता है तो both go up. मुश्किल assignment आती है टाइम कम मिलता है अगर they both go down. Without going into the cause, is A causing B or is B causing A or is a C causing A and B? Without going into that, at this stage, basically covariance will only help you say, okay, is there a statistical linear relationship between these two or not? Okay. Now, if you plot these out, you will see that okay, if you put the marks of A here, B here, it may look something like this thing. अब वो green line तो नहीं आएगी because we are not dealing with deterministic problems. Randomness है थोड़ी. ठीक? Teacher की grading में भी होती है. Maybe one of you submits exact copy of the other student and still get a little bit different marks. Because the instructor is also human. एक दिन चेक किया तो थोड़ा ज़्यादा दे दिया, दूसरे दिन उसी की कॉपी चेक की तो थोड़े से कम दे दिया. So they are sorry. Right. So, but notice, although they are spread out randomly, and we know they don't make a really smooth line, deterministic here, but do you see a linear relation between them? The overall, when A is high, B is, or A is high, B is high. When A is in the middle, B is also mostly middle-ish. When A is low, B is also low. What about this case? If it weren't like this, let's say you had plotted, this is called a scatter plot. Okay, so if you had plotted their marks, not these ones, another set, and it came out like this. Do you feel there is a linear relationship or chance of a linear relationship here? Why? See, here A is high but B is low. तभी ये point बना है ना? Yeah.
यहाँ पर आप इनको रिलेट कर रहे हैं B को, तो अलग-अलग ग्राफ के माध्यम से रिलेट कर रहे हैं.
We are interested in seeing how they co-vary, right? तो फिर relation है अलग-अलग में तो you can just see mean and variance, yes, and mean and variance of this guy. Yeah. Now we are interested in seeing does one random event or phenomenon affect or have similarities or linear relation with another random phenomenon. And जो बहुत commonly ये हमें जरूरत पड़ती है. Okay. So if the temperature goes up, does the car's performance go down? अब होता है आपने in a deterministic world you just draw a line and you will get the answer. But in a probabilistic world थोड़ा बहुत चीजें ऊपर नीचे होती रहेंगी. So you want to find, okay, is there a statistical linear relation between these two random events or not? Okay, I'll tell you why we want to know that. Actually, once we know that, we are often able to then look into the details of whether one is causing the other or is there something else that's causing both of them. फिर वो आप study करते हैं. लेकिन apart from that, there is another very useful information. See, if I tell you that A and B have a very high positive covariance, that means that one of them gets high marks, the other gets very high marks. When one of them middle-ish, the other gets middle-ish. Now I tell you that A, in a particular assignment, A got 1 mark. What are the chances that B got 10 marks? Very high. High or low? This case, if A got 1 mark, what are the chances that B got 10 marks? So I'm telling you where covariance comes in handy. याद है? I said all of this what we are doing is for what? एक तो grade के लिए credit चाहिए, right? Other than that, why do we study all this? To make decisions and to design things, right? If this information can help you predict the behavior of your car, your monitoring system, your AI module, your machine learning algorithm, if knowledge of one set of data can help you say something about the other set of data, that's very powerful. Why is that powerful? It can help you predict, plan, design, decide. Yes? So even in this very simple case, if it is established that they have a very high linear statistical dependence, even if you can't tell me if this guy got 1 mark, you won't be able to tell me exactly what marks the other guy gets, yeah? And it could be that the other guy still gets 10 marks, yes, but what are we talking about? Statistical relation, probabilistic. The probability of that happening at least is very low, given that they have a linear statistical relation. So this is it. Now sometimes things have a negative linear relationship. Okay, in that when one of them goes up, the other goes down. Okay, and usually that if you plot a scatter plot for that, that will look like this. Okay, does this have information or not? क्या है इसमें तो कोई इंफॉर्मेशन हमारे पास नहीं है क्योंकि they are all over the
It's hard degree.
So negative linear relationship is as useful as positive linear relationship. Why? Let's say these guys had negative linear relationship. When A got very high marks, B got very low marks. Let's say they had this. Now I tell you that A got 2 marks. What are the chances that B got 10 marks? Very high, because of when there is negative linear relation. So negative linear relation is as useful as positive linear relation. The only thing that's not useful is when this relation becomes fuzzy. Itna hi phailta jayega, things are all over the place. There is nothing statistically. I cannot see a pattern. Yes. So now ये जो मैंने आपको बातें बताई है ना, इस सारी को all of this, the one parameter covariance covers it. Okay. Take one random variable, take its values, take another random variable, take its values, take the covariance. If it comes out to be high, we will define what is high and what is low. But if it comes out to be high, there is good information in there, there is good linear relationship between the two. If it comes out to be low, low means towards 0. Negative in this case is not low. Okay, -1 is as useful as +1. Okay, -1 is this guy, +1 is this guy, yeah. But what's not useful is going towards 0. उनकी कोई linear relation, if you cannot find it, then statistically the predictive value of that information for one is very low. कोई फायदा नहीं रहता. Yeah, knowing one doesn't help you say anything about the other. Right, so we already wrote the formula for that. So क्या था formula covariance का? हमने अभी वो term we decided to find that. From here on we will just use the formula directly. It was how much does x, the first random variable or one of the random variables, deviate from its mean, times how much the other deviates from its mean, and the likelihood of those happening. Expected value यही करती है ना, it puts the averages or probability density function in there. Okay, so this is the formula that helps you answer this question, and often we normalize it to get something called correlation. Okay, so this is covariance. Covariance can have any values, 1000, 0, -1000. In one set of problems, 1000 may mean very high linear relation. In another set of values, even a 10 may mean very high, depending on their actual values. So in that case, this is problematic. So often we replace it by correlation, which is a normalized version of covariance. This is what it does. It says, okay, we take covariance of x, y. We're going to divide it by square root variance of x times variance of y. Now the good thing about this, mathematically you can prove it, that this parameter will always be between -1 and 1. Okay, I'm not going to prove it now, but this parameter correlation we call it. This is covariance and its normalized version. Normalization का पता है? कौन सी है मोस्ट कॉमन नॉर्मलाइजेशन क्या है? सब करते हैं. कौन सी
रिग्रेशन
नहीं नॉर्मलाइज करते हैं ना आप डेटा को फिक्स वैल्यू परसेंटेज yes percentage if I tell you a student in particular university got let's say 100 marks and in another university another student got 80 marks you may think okay the one getting 100 did better but maybe he got 100 out of 150 and the other guy got 80 out of 100 so values when their magnitudes are not normalized don't mean much right what do you do then you talk about percentages or GPAs yeah so when you say this guy got 80% marks this guy got 82% now you don't need to know anything else yes you normalized now the normalization we normally use is what over 100 yes so 100 is the max in this case we just normalize the covariance by the actual variance of the data and it can be shown that the covariance is always between -1 and 1 okay this sorry the correlation and this thing helps us decide usually if this correlation value comes close to 0 the statistical linear relation is low for this case it will be almost 0 for this case it will be nearly +1 for this case it will be nearly -1 जबकि इसकी values they can be 1000 -1000 million depending on the किस चीज को आप देख रहे हैं are you talking about marks are you talking about sizes of planets अब size of planets तो फिर पता है multiple thousands of kilometers में चले जाएंगे तो actual value बहुत high आएगी covariance की आप समझेंगे वाह बहुत covariance होगी but you haven't normalized it yet yes so covariance is good to calculate but interpretation wise this is the guide that helps us okay so this is just a additional thing here let's see this is one and then you can go from 2 to many you can skip that one last thing I want to mention on this subject we have already touched on that it's a very common fallacy or mistake people make in logical conclusions or decision making it is that they sometimes think as in this case that correlation yes they have a high correlation implies causation okay so they think that if two random variables are correlated very highly correlated they think that one is causing the other that is not true okay so this is very important to keep in mind I'll give you an example they did a study of people drowning in Sweden yeah, over several years yeah and then on one side they wrote ice cream consumption in the country divided and the other side they wrote drowning incidents you know what they found when people ate more ice cream there were more drownings okay so there was a very clear statistical linear relationship between the two आइसक्रीम जब कम खाई जाती थी तो कम लोग डूबते थे क्या हो रहा है इज आइसक्रीम कॉजिंग द ड्राउनिंग या डूबने से पहले दिल चाहता है बंदे का आइसक्रीम खाने व्हाट्स गोइंग ऑन यस सो important thing is this even if there is high correlation it does not imply causation this is one important thing you need to keep in mind when working with correlation you can say yeah I know if ice cream consumption goes up drownings are also going up that is useful information for me but I'm not going to just say without actually looking into the details whether ice cream is causing drowning क्या क्या हो रहा है क्यों ऐसा डेटा क्यों दिखा रहा है चांस ही तो स्टेटिस्टिकल चांस कह रहा है कि है रिलेशन
इनका रिलेशनशिप इस तरह
अच्छा ठीक है चले तो बहुत ही अजीम कोइंसिडेंस और कोई वजह ये तो सबको समझ आ रही है कि आइसक्रीम ईटिंग कैन नॉट कॉज ड्राउनिंग unless उसमें कुछ मिला हुआ होगा।
जो आइसक्रीम खा रहे हो वो मोटे हो
Okay.
जल्दी बोलो
So now you are going to a third variable, C, the obesity. Yeah, for example. So you're saying something else is causing these. Yeah, that's fine. Yeah. So basically होता ये है कि समर में लोग आइसक्रीम ज़्यादा खाते हैं, समर में बीच पे ज़्यादा जाते हैं, तो बीच पे ज़्यादा। ठीक है, इतनी सी बात है, right? So a third thing was causing that. अगर आप यहाँ पे एवरेज टेम्परेचर उस महीने का निकालें, वो भी ऊपर जा रहा होगा, यहाँ वो ऊपर जाएगा तो ये भी ऊपर जाएगा, ये भी ऊपर जाएगा, वो नीचे जाएगा तो ये भी नीचे जाएगा, ये भी नीचे जाएगा। Yeah. So correlation between two random variables, if there is a high correlation, it does not imply causation that one is causing the other. Okay, that doesn't mean it doesn't have information for us. I already said even without the cause or correlation thing, if there is a high correlation between two random variables, knowledge of one can help you predict the outcome of the other with some good estimate. है ना, probability theory है, you will not always be right, but in most cases you will be right in your guesses. ठीक है? So you can also go from two to many. The last thing I want to mention about the mean and variance, etc., is, at least in this module, is that the knowledge of mean variance is extremely useful in many ways. One particular use of it is in the form of Chebyshev's theorem. Chebyshev का नाम आपने सुना होगा, ये inequalities आती रहती है, Russian mathematician. Right, he proved that if a random variable x has mean mu x and variance sigma x square, meaning that it has standard deviation sigma x, okay, then even without knowing anything else about this random variable, okay, I can tell you what are the chances that this random variable will take values between, let's say, two standard deviations of its mean. So if x, random variable x, has values in a particular range, and you tell me its mean is here, and its standard deviation, which is the square root of the variance, is this much, mu minus sigma here, mu plus sigma. I can tell you what is the probability that this random variable will take a value within, let's say, one standard deviation within two standard deviations of the mean. Okay, so this probability is where it's saying what's the probability that the random variable falls here, not outside. It falls within two standard deviations of the mean. And Chebyshev's theorem says that this will be at least 3.3 by 4. In fact, the theorem says that we can tell you for any number of standard deviations, k standard deviations. So what is the chances that x takes a value within k standard deviations of its mean, and that is, sorry, greater or equal, because it's upper limit, lower limit, sorry, 1 minus 1 over k square. Okay. You want to find, okay, what are the chances that the random variable lies within one standard deviation, either like क्या chances हैं? You can get an upper limit by putting k equal to 1 here. If you want to see what are the chances the random variable will lie within two standard deviations, ये है ना, mu plus 2 sigma and mu minus 2 sigma. You put 2 here and get that. You want to know 3 standard deviations. Now the beauty of this theorem is that we don't even have to find the or look at the probability distribution of this random variable. Only ये दो parameters से हम काफी कुछ कह सकते हैं. Okay, this was just to show you one of the powerful uses of moments. Okay, you can start skipping the PDF and start working with mean variance covariance. Okay, so that concludes the third module of the course, and now we still have time, of course. So this was just to close the covariance part. This covers first, second, third chapter of your book, which will be the material of the mid whenever it happens. But we also want to do some practice on what we have covered. I've already sent a message 2 weeks ago to you guys through your CR to start going through the book exercises, other problems that you see. But first, do you have any questions on this? We covered what? Mean variance, covariance. Yes? What was this was the third module. What's the first module? Talking about uncertainties. P of A, P of B, so on. Second module, collecting those uncertainties in functions. PDF, CDF, conditional CDF, all that. Yeah. Third module, extracting key information from the PDFs. What was the key information we talked about? Mean variance, covariance. Yes. I skipped their cousins, which are not mathematically rigorous, very simple. The mode, median, range. कोई मसला नहीं. Range क्या होती है? Take all the possible values of random variable, subtract the minimum from the maximum, वो range है. Yeah. So they are not very rigorous like these. So I covered the key ones. बाकी फिर आप देख सकते हैं. So any questions on this? Otherwise, I will shift to some problems. नहीं है? तो मैं जाकर चलता. Okay, let's start here then. Now, please, I've been mentioning this before. Please make very brief summary notes of the 3 chapters or the lectures you have had. Summary notes in Radia. It should be very brief. The probability of A union B is PA plus PB minus PA intersection B. If PA intersection B equals 0, A and B are mutually exclusive, right? Like that. Okay, probability A given B is this. If PA given B equals PA, they are independent. Just not memorizing the formulas. That's not the main objective here. It's connecting the key information, mutually exclusive, equally likely, the joint probability, the joint conditional, all that. Yeah. So prepare that sheet, and for a particular chapter, if you're solving problems for there, look at that sheet. Look at the problem, and then look at that sheet. What's the information in there? That should help you solve this problem or that problem. Yeah. If you feel that the key information was missing, that you couldn't solve the problem, then put that key information. Right. So let's see. An experiment consists of flipping a coin and then flipping it a second time. If a head occurs, ये क्या किया हमने? पूरा ये क्या है? Experiment. याद है? 5 steps of assigning probabilities. Define an experiment. ये हो गया define. हो गया. दूसरा step आपने करना. What's the second step? वो लिख दिया. Universe of possibilities क्या है? इस experiment में what is possible? Right? वो क्या है? ऐसे बताएं. पेपर पेन से ट्राई करें और पेन से बताएं. Experiment समझ आ गया? Now, one thing students have trouble with in probability theory, usually the problem statement is this big or solution is small. Okay? So you could really have good comprehension skills. या उसकी जो लोगों को ये तो अभी छोटा problem statement में डाला है, इतना टाइम नहीं है यहाँ पे. They get really bigger. Okay? So डरना नहीं है, तो घबराना नहीं है आपने. ठीक है? So क्या है experiment को बता सकते हैं simple अल्फाज में? Easy है. So लिख लिया sample space. क्या है? 4 values हैं उसमें. नहीं वो तो हो गया, चलिए लेट्स से 4 है, वैसे 4 नहीं था ये आंसर क्या है?
सर हेड टेल
बस ये एक कॉइन है और एक डाई है ना, दो कॉइन्स नहीं है। Experiment consists of, ये मैं इसे डाला है just to show you कि even such simple thing could become complicated अगर practice नहीं होगी ना, so please। अब इसमें तो conceptual कुछ इतना मुश्किल नहीं है इसमें। This probability theory requires a lot of conceptual thinking. So it says, okay, you flip a coin and then flip a second coin if a head occurs. तो आपने कॉइन फ्लिप किया या अगर हेड आया तो एक और कॉइन फ्लिप करेंगे, अगर हेड नहीं आया पहले टाइम तो क्या करेंगे? डाई रोल करेंगे, ठीक। अब इस एक्सपेरिमेंट में क्या रिजल्ट्स आ सकते हैं? शुरू हो जाए ना, तो ये बताएं हेड किया आपने, हेड आ गया, ठीक है, कौन सी ये कंडीशन मीट हो गई है ना, तो आप क्या करेंगे? कॉइन दोबारा करेंगे कोई, उसमें क्या हो सकता है? ये तो हेड आ सकता है। तो अब ये हुआ कि हेड के साथ
टेल और हेड तो नहीं आ सकता, टेल आ गया तो फिर डाई कास्ट होगा,
टेल आ गया तो फिर डाई रोल करनी है।
हाँ तो सर टेल
नहीं सेकंड की बात हो रही है, सेकंड। फर्स्ट में तो एच लॉक करेंगे ना, एच 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 टी, टी एच तो नहीं हो सकता क्योंकि आपने जैसे बता दिया जो ही टी आया 1 2 3 4 5 6 आ गए सेकंड में, तो क्या बना? T1 T2 T3 T4 T5 T6, सही? या
HT1
नहीं, कंटिन्यू नहीं करना, हमने सिर्फ दो ही चीजें करनी है। वो एक्सपेरिमेंट उसका नहीं कि चलता है, फिर तो सैंपल स्पेस काफी मुश्किल है।
सर एक तो ये था ना कि अगर फॉर एग्जांपल पहली दफा हेड आता है, दूसरी दफा टेल आता है और आप डाई कास्ट करते हैं, ये भी हो सकता है कि पहली दफा में टेल्स आ जाए और आप फिर डाई कास्ट करें,
तो वही
ये
है।
दो सेपरेट हो जाएंगे। ये तो दूसरा वाला केस हो गया ना जिसमें पहली दफा टेल आता है, अगर आपका हेड आ जाता है फिर टेल आ जाता है,
इसमें थर्ड है ही नहीं ना, जो आपने you have to stay within the experiment, yeah you can change the experiment and you will change the sample space। इस एक्सपेरिमेंट में जो आप कह रहे हैं वो पॉसिबल नहीं है, इसमें दो ही काम करें, पहला तो होना ही है कॉइन, दूसरे में या कॉइन टॉस होना है या डाई रोल, दैट विल बी डिसाइडेड बाय द आउटकम ऑफ द फर्स्ट वन। लेकिन कोई तीसरा ऑप्शन रखा नहीं ना हमने इस एक्सपेरिमेंट, जाएगा वो मैं आपको एग्जाम में डाल दूंगा, ठीक है, एक तीसरा ऑप्शन है।
मैंने वो स्टेटमेंट
हाँ नहीं ठीक है, यू आर राइट। अगेन द इम्पोर्टेंस ऑफ स्टेइंग विद इन द एक्सपेरिमेंट, वरना तो आप वर्ल्ड ऑफ पॉसिबिलिटीज इसको हम सैंपल्स के लिए डिफाइन नहीं कर पाएंगे, बहुत मुश्किल होगा। Right, good. So ये we saw the combination permutation, उसमें common sense वाली चीज़ है, लेकिन आप बुक में लिखी है तो आप just gonna repeat it here. It's very common and easy to see. There are two things happening and one can happen in one ways and the other can happen for each, and one it can happen in two ways, then the total ways they can happen are n1 and n2. Right? If you throw two dice, एक दफा डाइस थ्रो करते हैं फिर दूसरी दफा करते हैं, पहले में क्या कितने ऑप्शन हैं? 6, दूसरे में कितने ऑप्शन हैं? 6। अगेंस्ट ईच वन ऑफ द फर्स्ट देयर आर 6 ऑफ द other, and the first is also 6, so that's n1 is 6 and 2 is 6, 6 times 6 36. So without actually writing के 1 1 1 2 2 1, you can count without even writing them, right? So 36 only, this is all this thing. So now इसका क्या है? How many sample points are there in the sample space when a pair of dice is thrown once? दो डाइस हैं आपने थ्रो किए एक ही दफा, राइट? तो कितने सैंपल होंगे? अगेन 36, यस। सो इन माय एक्साइटमेंट मैंने आपको जवाब ऑलरेडी दे दिया, वो डिफरेंट था, पर यस 36, बिकॉज एक वन the first one can show 1 to 6, the second can also show 1 to 6, पहले आपने रखे doesn't matter, so 1 1 1 2 1 3 so on, so it is of course 36 possible ways. Let's make the problems more interesting. समझ आ रही है क्या लिखा? If one in 1 year 3 awards, research teaching is beginning to a class of 25 graduate students. Right? Graduate students हैं इसलिए teaching और service भी चाहिए थी साथ. In a statistics department, if each student can receive at most 1 award, how many possible selections are there? किस चीज़ का प्रॉब्लम है? हमने किया था ऐसा कुछ? So your notes for chapter 2 should have those we discussed. Counting, yeah. We discussed when you use the power law, when you use NPR, when you use NCR, computations, permutations, combinations, yeah, or combinations. So इस case में क्या होगा? What were the 2 questions I told you about to ask? Yes. So is repetition allowed? Yes. And does order matter? So क्या कहते हैं आप इसका? Repetition allowed है?
एक बंदे को
एक शख्स को आप दोबारा 25 स्टूडेंट है ना, तो अली को आप 2 अवार्ड नहीं दे सकते इसमें. अली को 2 दफा नहीं चुन सकते. बेसिकली आपने ये 3 ताज बनाने हैं, राइट? 25 लोगों को ऐसे ही है. एक को 2 नहीं बना सकते. ठीक हो गया? ताज तीनों फर्क है, राइट? सो नाउ इफ यू चूज और यू चूज और यू चूज, कितने तरीकों से ये हो सकता है? सो ये बता देंगे ये कॉम्बिनेशन का प्रॉब्लम है या परम्यूटेशन का? परम्यूटेशन क्यों? इट्स अ प्रॉब्लम ऑफ परम्यूटेशन, बिकॉज अगर अली को आप रिसर्च का ताज बनाएं, इट्स डिफरेंट फ्रॉम गिविंग हिम टीचिंग अवार्ड, राइट? दे आर नॉट इंटरचेंजेबल, right? So repetition is not allowed, and order, in this case order means कि किसको research मिला है, किसको teaching मिला है, ये भी फर्क है, is mattering, it matters, या जब हम कहते हैं ना 3 को आपने research award देना, repetition is not allowed, फिर ये problem होता combination, right? फिर distinction ना रहती थी, अली को सिर्फ और को ये right? So total population 25, 25 student. You have to choose 3 in a way that repetition is not allowed and order matters. Yes. So this is a problem of permutation. Just right. आता है कि factorials को याद कर लेते हैं. Calculator में भी हो जाता है. That is the matter of identifying. So if you are lost here, that means कि अभी आपने वो जो हमारा डिस्कशन थी काउंटिंग पे, you still need to revise that and summarize that somewhere. उसके बाद भी प्रैक्टिस चाहिए होती है. Okay. Now we jump to probability actually. Yeah, with the sample space or just that counting किया ना, क्या कह रही है? A coin is tossed twice. What is the probabilities, or at least one head occurs? क्या है ये से one by 2. So how would you solve it? My suggestion is always start with the either event. The event is clear that at least one head occurs. Then sample space. Yes, sample space क्या है इस problem की? Coin is tossed twice, right? So head head, head tail, tail head, tail tail. यही है, क्या? Probably that इनमें से कितने events हैं जो 3 of them have at least one head. So this was your event. Your sample space में लिखी नहीं है, but you know it's HH, HT, TH, TT. Yeah, the total world of possibility. Now, if they are equally likely, if you remember, then I said you can simply apply counting. So since these all 4 which are equally likely हैं या नहीं by the way, head tail tail head tail. There is no reason to think fair coin अगर होता है normally there is no reason to think head ज़्यादा chance और tail का कम chance है, right? So that's why you can assign probability. So even if you skip this part, you know the total number of possibilities are 4 and the number of possibilities in A or events in A are 3. So remember हमने किया था when events are equally likely. So if events are equally likely, then what we can do is probability of A is size of A divided by size of your sample space. इसकी कंडीशन मैंने साथ लिखी थी कि these contain जो इसके अंदर events हैं they are all equally likely. अगर ऐसा ना हो ये फॉर्मूला नहीं लगा, ठीक है? So in this case S had 4 values. S का size 4 था. Yes, H H H T T H T T 4 all equally likely. A, the event that we were interested in was A, that is at least one head. वो कितने बनते हैं 3. So TT fails that condition. Yeah. So 3. So 3 here, 4 here. That's the probability. Was easy, just warming up. Yeah. Okay. Let's move to something more interesting. Now, एक unfair coin को हम loaded कहते हैं. Okay. So a die is or a die. Loaded means it's not fair. Fair die is 1, 2, 3, 4, 5, 6 equal probability. Yeah. In this case, it's saying it is loaded in a way that an even number is twice as likely to occur as an odd number. So without going into the physics of that, he ऐसा बनाया कैसे किसी actual वाला मुश्किल होगा ये. But just for the interest, if E is the event that a number less than 4 occurs on a single toss of the die, find probability of E. अब क्या करेंगे? यहाँ पे एक condition violate हो रही है. That is, the events are not equally likely, are they? So don't apply that size वाला. Okay? ये मैं इसे डाला आपको बताने के लिए. Equally likely नहीं है events, don't apply that. Okay? You have to now find their probabilities. Okay? So क्या करेंगे, कैसे करेंगे? Any thoughts? First tell me, even what are the possible outcomes? पहले ये बताओ, क्या है possible outcomes? One, two, three, four, five, six. यही आएगा ना, ठीक? What's the probability of 1? नहीं पता. Call it alpha. ठीक? What's the probability of 2? 2 alpha. Twice as likely. Yes. What's the probability of 3? Alpha. 4, 2 alpha. अब alpha कहाँ से निकलेगा? कोई बता दो. सबका सब मानना चाहिए. That is what we studied in the axioms. When we said the first fifth step was the probabilities assigned must make sense. Yes, the sense is that the total probability should be 1. मतलब आपने कुछ मिस कर दिया या कुछ ज़्यादा डाल दिया ऊपर चला गया. So you say okay, the sample space is 1, 2, 3, 4, 5, 6 as in any regular rolling die case, but I cannot simply count them because they are not equally likely. So now first I will have to assign their probabilities. Now the probability of this is alpha, this is 2 alpha and so on. So क्या बनेगा? कितने अल्फाज हैं? 3 अल्फा और फिर 2 अल्फा, यानी 6 अल्फा, right? So should be equal to 1. Right? So then what happens? Alpha is 1 by 9. So the probability of each of the even to twice rather. So what's the probability of 1? Alpha. Alpha हमने निकाल लिया. क्या है? 1 by 9. What's the probability of 2?
2 by 9.
2 by 9. Now अब इसका जवाब. What's the probability that a number less than 4 occurs? Less than 4. Yeah. तो इनकी बात हो रही है. Yes. ऐसे ही है ना. इनकी probability सब आपको पता है. 1 by 9, 2 by 9.
4 by 9.
जमा कर दें. क्या? So ठीक है. That was in magical. Again क्या होगा? If you अगर जब आपने नोट बनाया तो आपने सिंपली लिख दिया कि सर ने लिखा हुआ था कि प्रोबेबिलिटी ए साइज ए डिवाइड बाय साइज एस. साथ ही नहीं लिखा कि ओनली अप्लाइज फॉर इक्वली लाइकली सिनेरियोज. आप क्या करेंगे? इस पर भी वही लगाएंगे और खुशी खुशी दोस्तों को बताएंगे बिल्कुल बेहतरीन एग्जाम हो गया. राइट. बट इट विल बी रॉन्ग. ओके. सो अपने कॉन्सेप्चुअल नोट्स को बहुत क्लियर आपने समराइज करके रखना है तो फिर उसकी प्रैक्टिस करना है. जैसे कोई क्वेश्चन है समझ आ गया? What is the probability of getting a total of 7 or 11 when a pair of fair dice is tossed? एक्सपेरिमेंट क्या है? फेयर डाइस है, टॉस किए गए 2 है. ठीक है. तो उनका जो सम बनता है पहले पे मतलब व्हाट्स द प्रोबेबिलिटी ऑफ गेटिंग अ 6? 0. यस. क्योंकि एक से मिनिमम भी वो क्या दिखा सकते हैं? एक्चुअली 6 तो आ सकता है. सॉरी. बट देयर आर नंबर्स दैट कैन नॉट शो दैट. यस. ओके. This case we want to see, okay, what is the probability that a 7 or 11 shows? कैसे करेंगे?
पहले चेक कर सकते हैं कि 7 के लिए क्या पॉसिबल आउटकम लो
कितने हैं?
फिर 11 के लिए चेक कर लेते हैं.
हाँ. राइट. तो 11 के लिए कितने? जरा इजी केस है.
11 के लिए 2.
2 है. क्या क्या है?
5 plus 6 और 6.
राइट. That's 2. 7 के लिए थोड़ा सा ज़्यादा होंगे लेकिन नॉट इम्पॉसिबल टू क्विकली जॉट डाउन कि कितने बनते हैं. राइट. कर लेंगे. 4 3 3 4 5 2 2 5 लाइक दैट. 1 6 लाइक दैट. सो अब सारी की सारी पॉसिबिलिटीज themselves equally likely है. 1 6 is as likely as 6 1 is as likely as 6 6 है ना. वो तो equally likely है. पर सम में ये बात नहीं है. सम में 7 is more likely than 11 क्योंकि 7 के कॉम्बिनेशन ज़्यादा बनते हैं. राइट. बट दैट्स a separate story. So yes, you are right. You can what you can do is, remember we are saying 7 or 11. Yeah. So either do like this. You don't actually need this formula. You can do it directly. In this case, there are 6 ways. 7 occurs in 6 ways. 11 occurs in 2 ways. Total are 9 ways. Yes. Or 6 or 2. Sorry, 6 or 2. 8 हो गया. There are total 8 ways. And so total possibilities हैं 1 1 1 2 2 1 6 6 है. 6 times 6 36 है. They're all equally likely. So you can do directly from here. You don't need to do. ये हमने वही किया. Size A union B divided by size of the sample space. Right. Okay. More interesting. This is closer to what the actual questions in probability are like. Okay. लंबा चौड़ा एक्सपेरिमेंट की सिचुएशन होती है. क्या है ये? Suppose the manufacturer specification for the length of a certain type of your cable are 200 plus micron. It is known that small cable is just as likely to be defective as large cable. That is, the probability of randomly producing cable with length exceeding this much is equal to this much. The prediction says also that is not to be 0.99. What is the probability that a cable selected randomly is too large? Okay. So even if you can see the answer in some cases, I always recommend you carefully पढ़ें and start by defining events. Okay, क्योंकि when the problem gets harder, पहला part तो usually easy होता है. When it gets harder, brain में करना मुश्किल हो जाएगा, तो events will help you. What are the events you can define here? इस case में.
So ये 2 large का मतलब यही होगा plus 10 millimeter से ज़्यादा होगा.
2010 से ज़्यादा. यानी ये acceptable range है. तो क्या बनी? 1990 to 2010.
2010.
Yeah. So too large means above 2010, too small means below 19. उसके अंदर accept tolerance तो दी जाती है ना कि कितना acceptable है. So what are the events you can define here? Well, you can say it is large.
बस probability बहुत high दे रहे हैं उसी range में होगा.
But first let's define the events. क्या events define करते हैं? एक हो सकता है L event L, the other event A, B, C like that. Define your events L. Let L be the event that it's too large. Yeah. Let S be the event that it is too small. Then let M be an event that it meets. अब ये letters आपके अपने हो सकते हैं, अल्फा बीटा गैमा आप वाले पे लिख लेंगे. बोलते हैं अभी मैं इंग्लिश सीखा हूँ, मैंने कुछ और यूज़ किया. But always start by defining your events. Okay, so आप आगे देखेंगे L equals to long, S equals to short, M is the event meets specification. Right? What does that mean? Between 1990 and 2010. Yeah. So अब उसके बाद try to assign probabilities to these things and try to write the question in terms of these things. इनको define करने का ये मकसद है. Okay? ये जो 0.99 है, ये इनकी terms में किसकी है? M की है. Yes. Try the question means that the probability M. अब आप क्या कर रहे हैं? You are now putting this thing, reducing this thing to mathematics. फिर manageable हो जाएगा. Yeah. So probability M is 0.99. What is asked for? पार्टी ने क्या पूछा है? उसको भी मैथ में लिखें. Yes? क्या पूछा है? What is the probability that a cable selected randomly is too large? Yeah? So that is probability L. मांगी गई आप. तो बता सकते हैं क्या है?
सर ये 0.5.
0.05. Yes. So जो बाकी इंफॉर्मेशन इसके अंदर है उसको भी इनकी टर्म्स में पहले लिखने की जरूरत पड़ती है. ठीक है. What other information there is? They have already told you that being too large, producing too large is as likely as producing too small. So they are saying probability of too small is the same as probability of too large. Yeah. Now we know तीन ही हो सकते हैं, या too large होगा या too small होगा या specification meet करेगा. तो 0.99 तो उसने ले लिया. इन दोनों के लिए क्या बचा है?
0.1.
इनके लिए बचा 0.01. क्या? Since they have to be equal, दोनों को आधा आधा मिलेगा. Yes, exactly. So you divide that two, so 0.005. आप लोग शायद जल्दी से पूछो, but that would be 0.005. तो वो आंसर आ गया. हो गया? Okay. Part B. What is the probability that a randomly selected cable is larger than 1990 millimeters?
0.99.
Yes. So इस question को आप कैसे लिख सकते हैं? It will be that it meets specification. Yes. Or large भी allowed है. Yes. 1990 से ऊपर दोनों है. 2010 तक रहा तो M होगा और उससे ऊपर गया तो large होगा. ये दोनों allowed है. Are they mutually exclusive? They are. So you can simply make it PM plus PL. I think वही आपने किया है ना. 0.99 plus 0.005. 0.995. Good. So additional probability. Again, lots of information here. Yeah, थोड़ा सा time लेते हैं, पढ़ते हैं. Then start here. Events. You write the events. Then write whatever information you have here in terms of those events. Even the question asked should be written in terms of those events. फिर उसके साथ जल्दी शुरू करें. Yeah. तो इंडस्ट्रियल प्रोसेस है, इसमें क्या होगा, स्ट्रिंग्स और पर्टिकुलर ड्राइवर can be refracted in two ways, length and nature of texture. So okay, हम कह रहे हैं कि L, let's say L means is refractive in length, yes, and T means it's refractive in texture. मैं लिखने लगा जब आप कहें तो आप लिखने L equals refractive in length, T equals refractive in texture. So it is known from historical information the process that 10% will fail the length test. So what is the probability of L? Probability of L failing the length test, when refracted in length, is 0.0. Then the process at 10% states fail the length test. So length defective कितनी होती है? 10%. It is 0.1. Yes. So 100 में से 10 defective होती हैं in length. What's the probability that given one is defective in length? 10%. अच्छा. दूसरी information क्या है? 5% fail to the texture test. So probability of texture failure, defective in texture, is 0.45. Right? Then you have and only 0.8% fail both tests. इसको अब इसमें लिखेंगे.
0.008.
नहीं वो तो हो गया. Yes, L and T both happen at the same time is 0.008. Yeah. अब फिर सवाल क्या है? ये तो information, but the process is important. Okay. Problem भी easy है. So the process is important. Process is understand the experiment. Start with defining events. And write your information and the question asked in terms of these events. Okay. आगे फिर हम ये चीज़ variables के साथ. If you don't do that, आप सिर्फ देखते रहें, कुछ नहीं होगा. Unless you very intuitive और आप उसको देख के समझ आ जाएगी कि आप ठीक. So what's the question? Will you pass it up? Now start the rigor. Formula आप yes, so we have our knowledge base. Now in your summary sheet, there should be a formula relating conditional joint and probability A given B is probability A and B divided by probability B. Yes, but easy है तो याद में कोई टेंशन नहीं है. It makes sense. तो वो उसको यूज कर सकते हैं. Probability given L is probability L and T or D and L same thing, doesn't matter. So divided by probability of L, yes, which is not zero, so condition is also bad. तो डाल दें अब ये हाँ अब फायदा क्या होगा notice that often we come to these situations where we know things in bits and then we want to make prediction based on new knowledge that comes. Yeah. So and you got that right? Yeah. Makes sense. So ये slow में इसमें जा रहे हैं. I just want you to see कहीं उन्होंने भी events. Yes. Then write your questions in terms of events. You can still किया है आप P of L, P of T, whatever is given उसको भी events मिले. अगर आपके सामने आ गए मुझे बता के ठीक फिर आगे अब पूछा गया उसको भी events मिले. Then will be चलिए लास्ट वाला करते हैं फिर इसके बाद I asked कल problem session tutorial होगा basically right, so we can discuss. There are more problems here. आज से भी इस पे close करते हैं. One bag contains 4 white balls and 3 black balls, and the second bag contains 3 white balls and 5 black balls. One ball belongs from the first bag and they are not seen in the second bag. तो फिर मामला खराब कर देगा. एक से बैग देखे बगैर दूसरे में आ गया. Find the probability that a ball now drawn from the second bag is black. क्या करेंगे? So of course try to define your events, the scenario, the possibilities, right? So I won't take too long on this. I will see. आपको समझ आ रहा है इसमें हुआ क्या है? पहले में 4 white है 3 black है, ठीक है? Question क्या है? What is the probability that the ball drawn now drawn from the second bag is black? Right? So let's look at it and we can try to make sense of it. Again, कैसे start किया हमने? Defining events. Key thing. Because now this is first and second thing, so indices are helping us. B1 and B2 represent the drawing of black ball from bag 1, black ball from bag 2, and the white ball from bag 1. Right? So आपसे पूछा ही गया है कि what is the probability कि आपने जो second bag से ball draw किया है वो black है. So you are interested in B2. This is a problem of total probability. हमने ये किया है. Now what does that say? Again, second से black निकालने के साथ first में क्या क्या possibility? What could you have done? So ही है. Either you drew a black ball from the first one. Yeah? So there are only 2 ways you can get black ball from the second bag. Yeah? दो ही तरीके हैं. पहला ये कि आपने पहले में ब्लैक निकाली, दूसरे में आपने पहले व्हाइट, और तीसरा ऑप्शन भी है. ठीक? तो if you write this out and if you remember, we can reuse this thing as total probability or just replace it by the conditional formula and you can simply show that it's 38 by 63. Okay? तो याद है आपको मैंने जो किया था प्लेन अगेंस्ट सलमी कलंदर्स फॉर एग्जांपल याद करें ये वही है. ओके सो द सेकंड इवेंट कैन अकर इन ओनली 2 ways. वो 2 ways आप काउंट करें. So you have to sum them and you can replace them by the conditional. इधर हम क्यों गए by the way? Because it's easier to calculate. Okay, probability B2 given B1. Yes, very easy. Does this make sense to you? Probability of B1 is 3 by 7. What is saying? Probability that from the first bag, whatever you drew was black. क्या है उसमें probability 3 by 7. Does that make sense? क्योंकि पहले जगह में 7 balls and 3 black, and it's very easy. Yeah. ये directly हमारे पास नहीं है, इसलिए we mentioned here. Okay, so This one is interesting. What's the probability that the second ball drawn is black given that the first one was black? अब काम थोड़ा आसान है. कैसे? सेकंड बैग में जितनी भी बॉल थी उनमें एक ब्लैक का इजाफा हो चुका है. हो गया है क्योंकि आपने कंडीशन आप ये ले रहे हैं, पहले से आपने ब्लैक निकाल के उसमें डाल दी थी, तो उसमें एक बॉल का इजाफा हो चुका है और टोटल कितनी ब्लैक उसमें हो गई है, तो उससे आप निकाल सकते हैं. इसी तरह वाइट का भी आप कर सकते हैं. So yeah, I'll stop here. We will do some more problems on probability and on say distributions and functions. So any questions on that? Mid तो आप लोग कह रहे हैं अगले से बजाय उससे अगले, ऐसे ही है ना? ठीक, फाइन, मुझे मसला नहीं है, देखना. ठीक, राइट. Stop the recording.